recording. So if you do get behind or confuzzled, let me know. I've got Lab 3 up here. I've also got code blocks up here running. Okay. If you need a USB key, grab one, and you can run code blocks off there if you're struggling to get it running off the Google Drive. But for now, just follow along for a little bit. Here's what we've learned so far in class. Okay. Basically, the first thing we've learned is how to output words and numbers and math on the screen. The practice. Okay. That will type the word the practice on the screen. Wow. Exciting. First time I run it, it's a little slow, and then after that, it's better. Okay. I can also write math on the screen. Great. So I will write 1 plus 2 plus 3 times 5. Whatever I want, as long as it's not in quotes. Okay. It will run it. Great. It put 18 on the screen. I think that's the right answer. Excellent. Okay. Can I do both? Can I mix and match words and numbers? The sum of 7 and 5 is, and then I'm going to do a double arrow, and I can actually write 7 plus 5, and it will figure it out, and it will write that as a sentence, and mix the words with the math and the numbers and everything. The sum of 7 and 5 is 12. Great. So that was what we learned on the first day of our coding adventure. Just basic output, how to put stuff on the screen. Okay. The second day, we learned how to store information. And the only things we learned how to store are whole numbers for now. But you store them by writing the word int and then giving it any name you want. And then you use that name as though it were a number. So the first thing I want to do is let it equal 28, for instance. And then when I output, if I want to output 28, I can do it two ways. I could write 28 here. Or I could write num1. What's the difference? Num1 has the ability to change later on in my code, depending on any math I may do to it. So it's good to have a place to store numbers and manipulate them and do things that I want. Like, for instance, I could say num1 equals num1 plus 10. That's going to add 10 to that number. And then if I output it again, it'll be 38 instead of 28. Okay, so that's what a variable is, and that's what we've learned so far. Just one type of variable, integers. Lab 3 is going to ask you to make a character variable. There's two types of variables, actually, that we're going to learn today. The first one will hold decimals, and the magic word for that one is float. So I'm going to write num2 here like that. Okay, and that's going to hold decimal numbers. Holds decimals. So now I can make num2 equals any number I want with decimals. In the past, if I would have done that with an integer variable, it would have cut off all the decimals. But let's say I want to make this 8.7, something like that. Then I could do that, and if I output it on the screen, it will say 8.7. Okay, great. There it goes. Okay. Says it on the screen. So it's called a float. It stands for floating point arithmetic, which is a computer term meaning like the decimal point can move around. It floats, floating point. Can I mix and match an integer variable with a float variable? The answer is yes. Could I, for instance, do some math like num1 times num2? Will C+ allow it? And what will it do when I do it? Right now, num1 is going to be 38. If it times this by 8.7, I don't know what that's going to give me, but I'm going to try it out. Let's see if it's a decimal number. It looks like it's a decimal number. It looked like it did the math and kept the decimals. Okay? So I think it's important to know that when this computer holds in numbers, you actually have to tell it if it's going to hold I think almost 99% of the time when you make a variable that's going to hold numbers, you will use float. Because, you're not always going to use integers for everything. They're not as useful as numbers that hold decimals. The computer, the reason why they even give you the option to use an int and not just always float is because a computer is better at dealing with whole numbers than it is with decimal numbers, because it's got to switch them all to ones and zeros and stuff inside and then switch it back. And it gets really screwed up with decimals, and sometimes you lose precision in your numbers and you don't lose it in the integer ones. So, most of our variables this year will be floats if they're numbers. Okay. The third type we're going to learn about today is one, and it's not a very useful one either. I'm going to call it Char. Char letter is the name of my variable that I made. This one just holds one letter. Holds one letter. And you actually set it by making it, like, I'm going to let it equal the letter Y. You do it in single quotes. And you can see out that as well and see what happens. See out letter and end L, like that. It's not super useful. Some cool little tricks are, like, you can actually let it equal a number. Okay? So I could let it equal the number 40. And then I could see out letter. Like that. And it will actually convert it to a letter that is represented on the keyboard by the number 40. Now, how do you figure out, it's a bracket for, which is, like, how do you figure out the keyboard has only a certain amount of buttons, everyone must have a number associated with it. How do you figure out which buttons have which numbers associated with it on a keyboard? And it's on this thing called the Ascii Table. The Ascii Table is like an old-timey list of all the buttons on a old typewriter. And because a computer is much better at dealing with numbers than it is letters, it treats every button on your keyboard like a number. And back in the day, it treated everything on a keyboard like an old typewriter. So it's got all these weird ones like carriage feed, form feed, vertical tab. These are all things a typewriter would do. But you can see that there's like all the letters too, all the capitals, A, B, C, D. Like, let's see, the letter D here is 68. What if I let my character equal 68? Will it put a letter D on the screen when I go to print it out? Yes, it did. It put a letter D on the screen there. There's some really wacky ones in there I saw, like stuff you would make ASCII art out of, right? You ever seen ASCII art? Look at, let's look for like a dollar sign or something. Look at this one, an A and an E stuck together. That's 146. Let's see if I can get it to spit out an A and an E stuck together. I'm going to write 146. Whoa. Will it spit out an A and an E stuck together? Yes, it did. Cool, eh? So yes, you can make character variables, and yes, you can actually let them equal numbers, and you can let them equal any number on this table, and you can make weird characters. Okay? There's like DOS games where you play them. Dwarf Fortress is the big one, isn't that it? Remember that game? I think they're turning it into a graphical game, but back in the day, it used to be like all this weird ASCII art, didn't it? Look at this. This is what the game looked like. See, it's all these just weird ASCII symbols, and that's like your map and stuff. I think they're slowly building it up into a real game now. The graphics are still kind of dumpy. But that's kind of a popular game. There's some ASCII art, when they turn people's faces into... Look at this, a New York Times article from 10 years ago. Anyways, that's how you can make art with it and stuff. Okay? You could take pictures you like and turn them into ASCII art. ASCII art converter. You like throw a picture in there and it converts it for you. You see them in Twitch chat and stuff? When people put like, yeah, they'll put like really gnarly things on. You've seen it. Yeah. Let's get a one of Rick. Let's see if it'll do Rick. Nah, it's not gonna do it. Okay. But that's we'll save that for another time then. Anyways, Lab 3 has to do with a little bit about converting characters to numbers and stuff. So you'll see some questions come up. And try them out. Let me know how you do, okay? I'm going to post this video to YouTube right now.